Hi everyone. In today's video, we're going to see about auto research. Auto research framework is completely built for testing. When I say testing, technically it is for entire optimization and research and development work. Have you been in a situation where you wanted to test this application and you wanted to do much more research on that, like what kind of hyperparameter tuning that you can do and what all the fields that you can change and modify or update, but you don't have any time or people around you to do this. But if I say we have an application or framework to do this for you without even be your interaction. So an agent kind of framework where it does entire stuff by asking questions to itself and research by itself in browser or any web applications that you can just refer it to. All you need to give is LLM API key or anything that you have subscription for. Just that API call it makes and it does all the things by itself without even asking an user. So let's get started with auto research. As I said, it's a framework and it completely built for research and development. So it does everything by itself. You don't have to give any input, just the query that you need to define, and it does the entire research by itself. So the hypothesis generation, synthesis, step information retrieval, everything by replacing so many R's into a fraction of not second basically. If you are working for 9 hours of work, it can just reduce that into an half an hour, 30 minutes work. So if you need a lot of manpower, this can be done in a single GPU. So that is how it is done. Let us see some of the use cases for it and architecture. And at last, I'll just walk through a simple step how it is actually executed. So let's start with an architecture. We have this query, user interface where you have to give what you need. And it does the entire research by itself with this step. And finally, you'll get a research report. So orchestration layer, which will have a planner, memory storage, a reflector, and a synthesizer. So all these four will just understand your query step by step, and it will split each of your query and understand that using a vector DB by placing it in vector DB. And at last, you will have the agent layer. So it is simple. When you give a query, LLM will understand it using RAG. And with RAG, help of RAG, it understands by researching those topic what it is. With the storage, the data base it has. For example, I'll tell you. So RAG, how it does, it communicates using LLM. So when you give a query, based on the sources you referred for RAG, it may be a PDF or anything it may be, you just gave the data source. With the help of your query, it understands what it need to search. So it splits and extracts the topic from it and identifies what is there in the DB and gets the answer for you. It's a simple Q&A. With that, it is an elaborated version. RAG is used in order to understand what a user asked, and later agent will communicate within that themselves. Within the framework inside. So agent layer, which will search, and the reader agent, it will understand from what it is. The it may be any data source that we give, and the fact checker in order to reduce the hallucination, because the report should be precise. It cannot be compromised, right? So for the fact checking, we have a data source, right? So cross validation is happening, claims scoring is happening, and source trust. Yes. So source we give, and based on the reputation of the source, it understands and it quickly verifies those facts. And analyst agent, which will analyze the trends and hypothesis generation and gap mapping. At last, we will have the report drafting, style adaptation, and markdown outputs. So we are just organizing the research that it has done previously with the source and some of the facts which it cross validates. And at last, it maps with the appropriate research that it does with the query that we gave. And finally, we have this toolbars. It may be anything: a web, API, vector DB, core executor, LLM gateway, file reader. It may be anything. And at last, you will have the data source and the output where you will get the research report. So it is done. It may be a JSON format, CSV, or any blob through the web source or any toolbars. It extracts and gives us. So it is like simple that we do, right? How we build or generate reports. The same thing, but a machine is doing for you instead of you coming forward and verifying everything. At last, you will get a report. Once it is done, it is done. After that, you need to verify the reports and it is okay. You can proceed with the report. If any slight modification that you need to do, it need to be said from the user interface, and it just verifies again with the agent layer. And agent layer goes back with the fact checker again and removes or excludes some of the facts which said it is wrong or modifies those facts and maps it properly. That gap filling happens in the analyst. Yeah. So this is how the architecture works. Let's go with the live walkthrough. So let me ask, like, what are the best technique to reduce hallucination in large language models? Which is a huge, huge question till now that we don't have answers for. So the goal is planned. If you can see, it is splitted into tokens. Before that, query intake happens with a raw query, and it extracts topics from the query, which is not just word splitting. It extracts a topic modeling is happening just for the RAG. And goal has been planned with a feedback or any model, looping model that we can give. And search and retrieve. Here is a planning happens. Maybe any agent involves that it research with any tools that is available. It can go with the web search or any PDF file manager that we give path for. It can access any information that it has, but in general, it is a web source basically because it is a vast topic and we can't feed information about it. And read and extract the information, fact check, and reflect and score. So here we have this cross validation and all. Yeah. So read and fact check. We will have the source files, fact checker, which will have these things with the citations and all, so that it is paper which is published or any base paper it can take or any research model it can take, but it just verifies whether it is true or false. That's all. That is a fact checker. With the reputed pages, it will validate based on the sources that they are promised to. And here's a cross validation, as I said before. Synthesis. So we are like consolidating everything, grouping together what it had, what is not there, and so that it will have those information. If we are finding some of the flaws in it, the final results that it is not acceptable, or that we feel there is some flaws in it, we can get it back so that it can just refer back and include some of the information that it requires to modify for us, it will do. And finally, we have the results. So total execution starts, wall clock time, so 47 seconds. So it does everything for you. Executive summary and key finds, and it gives the sources also, like where it found those information. And yeah, Finally, report quality score that also it gives. So it does all the hypothesis testing, analysis, and fact checking. Everything it does by itself. So you don't have to worry about the final report. One, I won't say drawback, it requires a lot of memory to do this entire task because it is going to perform a group of people task. So we can't just say that it should do it in a local machine or something that we are like asking it to do. It is not possible. So that is why. I hope this video finds you well. See you all next video. Thank you so much for watching.